Hi class, here's the homework for Friday, April 25th. We started chapter 12. We started at 12.4. We'll go back and do 12.1 and 12.2 and 12.3 later. Okay, so this is the answer key for the homework. And we looked at the volume of prisms and cylinders. This figure here is a cylinder because it has circular bases. Number 2, this is a hexagonal prism. Remember, a prism has two bases that are parallel to each other and perpendicular to each other, or parallel to each other and congruent to each other. And they are connected by parallelograms from corner to corner. So this is a prism, and it's a hexagonal prism because the base is shaped like a hexagon. This is a rectangular prism. The bases are shaped like rectangles, and this has multiple choices of shading. I could shade the top here and then the bottom. Those would be opposite sides. I could also shade the ends. Those could be considered bases. And I could also shade the front of this and the back of this because they're opposite sides, they're congruent, they're parallel, connected by parallelograms shaped. I forgot to shade in the bases over here, the circle base, circle base. This has a triangular base, and so the bases here are, this is the top. See how that's a triangle? And it's parallel to the base on the bottom, and they're congruent. So this is a triangular prism. These are all prisms, and they're named for the shape of their base. Okay, find the volume of these prisms. So volume is equal to the area of the base, this big B, times the height. The area of the big base, or excuse me, the area of one of the bases, and the height is the distance, the perpendicular distance between the bases, for those of you who weren't here. So let's look at this. I'm going to use this bottom as my base, so the bottom and the top are the bases. All right, so first I'm going to find the area of the base. So base area is equal to, well, this is a rectangle, base times height, so it's 7 times 3, so that's 21 centimeters squared. So now I put that into our volume formula. Volume equals the area of the base, 21, times the distance between the two bases. In this case, is 4. So we get 84 centimeters cubed. And that's the volume. Number 6, looking carefully at this, you'll see that the top and the bottom can't be bases. They're not the same side. That these two sides cannot be bases because even though they're the same size, they are not parallel to each other. They both slope inward. So this front side right here is a base. It's a trapezoid. And this back side is the congruent base as well. So that's the base back there, and this is a base here. So volume equals area of the base times the distance or the height between the bases. Okay, so this is a trapezoid. We use the formula for the trapezoid. So the area, big B, is equal to 1/2 B1 plus B2 times the height. So I'm going to look at this figure here. We have 1/2 times 11 plus 19 times the height of 7. That's equal to 1/2 times 30 times 7. So that's equal to 15 times 7, and that is equal to 105. And the units are going to be cubed, feet cubed. Oh, I'm so sorry. This is the area. This is going to be 105 feet squared. So that's B. Now we need to find volume. So volume is equal to this B, 105, times the distance between the two bases. So if this is one of the bases and this is the other base, then this is the height, 8. So that's equal to 4. Allison, I can't do math. 4 840 feet cubed. So that's the volume. The area of the base times the height. Okay, number 7. The bases here are going to be these triangles. So this back base right here and this front base right here. This is the front base and this is the back base. Okay, they're congruent, parallel to each other, connected by the shape of a parallelogram. Volume equals the area of the base times the height. Well, the area of the base this is a triangle, so this area is 1/2 base times height. That's 1/2 times 14 times 3. That's 21 inches squared. So that's our big B. To find the volume, we take the big B and we multiply it times the distance between them, which is 10. The difference between the bases, that's 210 inches cubed. Number 8. Again, we look for the matching bases. This is a triangular prism. So this base right here is the front, and then the back is this one back here. So this is a triangular prism because the bases are triangles. Volume equals area of the base times the height. So the area of this base, well, because these two bases are congruent, if this length is 13, then this length is also 13. So we can use the Pythagorean triple to find this base, and then we can find big B. Remember, big B is equal to 1/2 base times height. We're trying to find the area of the triangle, and then we'll multiply it times this distance of 3. Okay, so using the Pythagorean theorem, you can do that. You'll find that this is 12. So this leg is 12 meters. All right, so I'm going to plug that in. 1/2, the base is 12, the height is 5. So that's equal to 6 times 5 is 30. All right, so the volume is equal to the base times the height. So that's equal to 30 times, now this is the difference between, don't use this as your height. We're looking for the distance between the two bases. So if this front is the base and this back is the base, then the distance between them is this 3. So we get 90 meters cubed. Okay. Next one. Again, we have a prism, but it's oblique prism, which means it's leaning over a bit. But the volume is still equal to the area of the base times the height. So big B is equal to, well, this base here is a rectangle, so it's 7 times 8. Base times height, right? So it's 7 times 8, and that's 56. And then we take, to find the volume, we'll take that 56 and multiply it times the height of 4. 224 centimeters cubed. And the area of the rectangular base here, and then multiply times the height. And number 10, there's a lot of different ways to find the area or the volume of this and the area of the triangles. Okay, so this is a triangular prism because this is a base parallel to that base. So this is definitely a triangular prism connected by the shapes of parallelograms from corner to corner. This makes a parallelogram, bottom is parallelogram, side is parallelogram. Okay, so we need to find volume. It's the area of the base times the height. So how do we find the area of this equilateral triangle? So we need to find B. Well, there's a couple different formulas you could use here. I'll use them both. So if I want to find the area using this equation, I'll use s squared rad 3 over 4. So that's equal to, well, the side of this triangle, I'm trying to find the area of this, is 5 squared rad 3 over 4. So that's equal to 25 rad 3 over 4. So I found the area of this equilateral triangle using this quick, simple little formula. Okay, so that's big B. Now to find volume, I take that 25 rad 3 over 4, and I multiply it times the distance between the two, which is 9. So that is 225 over 4 rad 3. Excuse me. And that is inches cubed. Excuse me. that was probably the easiest way to do it. You find the area of this equilateral triangle using this quick little formula. Now, if we want to try to do it using area equals 1/2 base times height, that's possible to do too. So let's just redraw this. This is the, I'm trying to find the area of this, and this is the rest of the prism back there. Okay, I'm not going to draw the whole thing. It's kind of abbreviated, but anyway, this is 5, this is 5, this back here is 5, so it means that this is 5. This is an equilateral triangle. So I could drop down my height. Now if I do that, then that means that this is 5/2 and this is 5/2. And not only that, I'll just get rid of that 5. Not only that, this is 60 degrees, so this is a 30, 60, 90 degree triangle. So if the short leg here is 5/2 and this 30, 60, 90, then the height is equal to 5/2 rad 3, right? This is a 30, 60, 90, so the short leg is 5/2, the long leg will be 5/2 times rad 3, and this is twice this. If I multiply 5/2 times 2, I get 5. So this is a nice way to do it. So now the area is equal to 1/2. The base is 5. And the whole base is 5. And the height is 5/2 rad 3. Multiply this together carefully. Then we get, remember the 5's on top, and rad 3 is on top. So you get 25 rad 3 over 4. And look, that area matches over here. Now we use that area to find the volume, so 25 rad 3 over 4 times this distance here, which is 9. And remember that 9 is in the numerator. So that is again 225 rad 3 over 4, and that is inches cubed. And that's our volume. And this was inches squared. That was the area. You could also use the Pythagorean theorem, which I don't recommend at all. But you can do it. It's a little messy. And if you did and you have a question about it, ask me in class. Okay, back side. Here is a 1, 2, 3, 4, 5. This is a pentagonal prism because the top and the bottom or the bases are pentagons. Alright, so remember the volume equals the area of the base, one of the bases, times the distance between them, the height. So if I'm going to find the area of this base right here, this pentagon, so I'm going to try to find this base right here. This is a regular pentagon, so base, the volume, the area of the base is equal to 1/2 apothem times p. So we have an apothem, and we're going to find, and we can find the perimeter as well. If this is 4, then this side down here is 4. Okay, so 1/2, the apothem is 2.8. The perimeter, if this side is 4, this is 4, 4, 4, 4, 4, 4 is 20. So the area is 1/2 times the apothem times the perimeter of 20. So that's 28 centimeters squared. Okay, so we found the area of one of the bases. Now we're going to take that. Volume equals 28 times the distance between these two is 5. This top base here and this bottom base, the distance is 5. So that equals 140, and that's centimeters cubed. All right, number 12. This needs to all be marked. This is a regular hexagon, and I didn't mark that, so sorry about that. So we can use, for volume, again, we're going to use the area of the base times the distance between them or the height. So how do we find the area of this base? We're going to use this formula, 1/2 A times P. So that's 1/2. Our apothem is 2 rad 3. What is our perimeter? Well, we need to know one of the lengths of the sides. So let's just look at this hexagon right here. I'm going to redraw it. And the apothem here is 2 rad 3. Well, this is not a very good hexagon, but in a hexagon, the central angles are 60 degrees because there's six central angles. I could sketch them in here. So each one of these is 60, 60. So if I have this apothem, it's going to cut this 60 degrees in half. So this is 30 here. So I didn't make it big enough. And this is 60 over here. This is a 30, 60, 90. So this apothem, if we draw the triangle, makes a 30, 60, 90. Okay, so if that's true, then if this long leg is 2 rad 3, then the short leg is 2 rad 3 over 3. Over rad 3. So that just makes it 2. So this is 2, and this is 2. So the side is equal to 4. All right, well, if the side is equal to 4, then we can just find the perimeter that way. 4 times 6 is 24. So 1/2 times the apothem, 2 rad 3. Using 30, 60, 90s, we can find that this is 2 and this is 2, which just makes this whole thing 4. Okay, half of 2 is just 1, so that's rad 3 times 24. So that's 24 rad 3. And that is our area of our base. Now to find the volume, we'll take that 24 rad 3 and we'll multiply it times the distance here between them, the height, which is 12. So that is equal to 24 times 12 is 288 rad 3. There's no units, so we'll just leave it like that. Okay, number 13. Find the volumes of the cylinders. Now, cylinders are just like prisms. They have parallel bases that are congruent, and the area is going to be equal to big B times h. But normally, since we know that the area of a circle is pi r squared, we're going to replace the b with the pi r squared. So this is our formula. V equals pi r squared times h. And that, like I said, this part is our big B. Alright, so volume equals pi. Our radius is 2, so that's 2 squared. Our height is 1. So that's 4 times 1 is 4 pi, and that's feet cubed. Okay, number 14. And find the volume. It's equal to pi r squared times the height. So pi, now what's our radius? If this distance, this diameter here is 20, then our radius is half of that. So our radius is 10. So pi times 10 squared, and then the height is 20. Okay, so that's pi times 100 times 20. That's equal to 2,000 pi feet cubed. Okay. And just like in the rectangular prism, we can also have an oblique cylinder where it's leaning over a bit. So the volume is going to be equal to the same formula, big B times h, which is pi r squared times h. So pi, our radius is 3, our height is 5, so this is 45, right? 9 times 5 is 45 pi inches cubed. Easy peasy. And then we're going to go into some review. Find the area of the shaded sector exact. So remember the formula for the shaded sector? It's area of the sector equals x over 360 times pi r squared. So we want this shaded area here, so that's 140 degrees. That's over 360 times pi. The radius is 3 rad 2 squared. And now we have to simplify this. Remember, we're going to leave pi as pi. We'll divide that by 10, so get rid of those. Now we can divide this by 2, that's 7. And 36 divided by 2 is 18. So we get 7/18 times pi. Now if we square this, the 3 squared is 9, and this rad 2 squared is 2. So that's 18 in there. Okay. So if we simplify this, we get 7 over 18. If we simplify this, we get 9 times 2, which is 18. Oh, well, that's nice, since these are in the numerator. We can just cancel one in the numerator, one in the denominator, and we get 7 pi. That's your answer. Okay, 17. If the area of a circle is 24 pi, find the radius. Okay, area of a circle, what's the formula? Area equals pi r squared. Well, the area here is given as 24 pi, so that equals pi r squared. And we're trying to find the radius. We're trying to get r. Well, let's get r by itself. Divide by pi, those cancel. And we get 24 equals r squared. Now, to get r by itself, take the square root. And we get r equals the square root of 24. We can simplify that as a perfect square factor. Let's take out that square root, so that's 2 rad 6, and that equals r. Now we're going to use that r to find the circumference. So circumference equals 2 pi r. So it equals 2 pi times 2 rad 6, which equals 4 rad 6, so that's our circumference. Okay, number 18, write the equation of the line in slope-intercept form. Well, that's a blast from the past. Okay, so this m represents slope, and b represents the y-intercept of this line. So if we can find the slope and put it in here, and the y-intercept here, we'll have the equation of this line. And that equation will give us all the points that are on this line. All right, slope is rise over run. So if we start with this point, if we go up 1, 2, 3, 4, 5, it's up 5, and we go over to the right 1, 2, 3, we get positive 5, positive 3, there's our slope. Our y-intercept is where the line crosses the y-axis, so that's it. There, so the y-intercept b is equal to 3. 1, 2, 3. So in our equation we'll write y equals slope 5 over 3 times x plus 3. Just plug the slope in and the y-intercept in. And this equation, like I said, will give us all the points that are on this line. Put in a value for x, you'll get out a value for y. It will be on this line. Okay, I'll see you in class next week, and have a great weekend.